I am Andrew Renninger. I am from the University of Pennsylvania, and I'm here to talk about the impact the pandemic is having on segregation in American cities. So I'll start with the structure of this talk. We're going to begin with a brief introduction. I'll go through the data and methods, and then we'll use two case studies to sort of walk you through the data and methods, and before expanding to some automated processes that I use to get data for the whole country. And then I'll conclude with a discussion about the results. So the introduction. The question I wanted to answer is, what impact has the pandemic had on segregation in American cities? And is there any evidence of lasting changes to network structures because of the shock of the pandemic? To answer this, we're going to look at experience segregation, a measure of how diverse your daily interactions are, rather than just how diverse the area where you sleep is. So residential segregation probably isn't changing much during the pandemic if people aren't moving, but the places that you move about throughout the day, those are likely changing as things like shelter-in-place orders and lockdowns are enforced. So I wanted to see what impact those measures would be having on the kinds of people that we're interacting with on a daily basis. Constructing networks from origin destination data, the hypothesis that we're going to test here is that detected communities in these spatial interaction networks will shrink in size and integration will fall. So using the definition that I just mentioned of experience segregation, the kinds of people that any given person will see on a daily basis will become more like themselves than before the pandemic. The motivation for this is pretty simple. I've seen a lot of literature, as I'm sure you all have, during the pandemic about how mobility and, to a lesser degree, segregation and even inequality exacerbates COVID, but less research sort of turning the arrow the other way. There's certainly work on how COVID is changing mobility, but there is less work on how COVID is impacting segregation. And so I wanted to sort of fill that gap. So my strategy here is to use data from SafeGraph. SafeGraph is a location data provider that gives visitor information for 5 million points of interest in America, and it allows us to construct spatial interaction networks with the venue location and the home location. When you sort of string them all together, you end up with something similar to what you see on the right here, basically lines connecting origins and destinations. And you can think of that as basically a graph. Then I'm going to use cloud computing because of the size of the data to draw down data city by city for the 100 largest in the States over 12 months. And at each iteration, I'm going to detect communities using a community detection algorithm in the network, join in demographic data, and look at how the demographic profile of these detected communities is changing. So the supposition here is that as we saw this giant shock to mobility, the community structure is going to change in the networks as people are moving around differently, and the demographic profile of these new communities should be different. And my hypothesis is that it will be more homogeneous, and people will be interacting with people more like themselves than otherwise. So the process laid out more succinctly is we're going to query data, we're going to construct a network, then we're going to compute a series of statistics. These are more sort of like along for the ride, but they're also covariates that can help us explain the phenomenon that we're really interested in, which is segregation. Then we're going to detect communities, join in demography, and then we're going to use a couple of common practices to calculate segregation. I'm not going to reinvent the wheel on anything. About those measures, The first that we're going to look at is graph correlation to look at changes in the structure of these networks. It's a little bit more of a thorny concept, so I have some correlation matrices over on the right here. Within each city, we're going to look at how the structure of the city in any given month compares to the structure of the city. This is its mobility network during all other months. And you can see here that April is really the key month when all the lockdowns were at their worst. But every city has its own sort of profile here, its own fingerprint. And some have other months that saw big changes to correlation. The graph correlation measure is sort of a way, it's a way to do anomaly detection or change point detection. It's to figure out how much things are different in the network. Network density is looking at how saturated the graph is. So it's basically in the numerator, you have the number of connections, and in the denominator, you have the number of possible connections. So n by n, where n is the number of nodes. And that's just a sign of how much sort of the network is going from dense to sparse throughout the pandemic. We're also going to calculate degree centrality, the average degree centrality in each city. So how many connections does any given node tend to have? And a node here is a neighborhood, remember, not an individual. Then we're going to move, and we're going to, as I said, detect communities using the InfoMap algorithm, and we're also going to collect average community size. From there, we're going to look at 3 different indices to measure segregation. The one that I'll put at the top of the sort of list, the top of like the most important, is dissimilarity index, which roughly asks how many people you need to move to make an even distribution of whatever variable you're looking at, in this case, race, throughout the city. So if you have one detected community that has a very high population of African Americans, how many of them do you need to move around the city so all the communities look the same? And then entropy index and Gini index are more robustness checks. They're not going to be so central to the analysis, but entropy is a measure of order, and Gini is a measure of concentration. You've probably seen it applied to wealth. So our first case study is the Bay Area. On the right here, I have a graph, or I have a graph and a map showing what happened throughout the pandemic. You can see that in March, you see your first drop in network density. This is because the Bay Area was one of the first cities to see cases in the coronavirus, and the map sort of phenomenologically grounds it. You can very easily see that it goes from a very dense network in January right here, and then things really drop off. The number of connections really drop off, and it becomes much sparser through the pandemic, and we still haven't recovered from that drop in network density to this day. So here's the correlation matrix. The Bay Area is still relatively similar to itself. It's still quite correlated compared to a lot of the other cities, but April is the low. April is also quite different from February, as you can sort of see on the matrix. But let's jump into what this means. So we have on the right here the average community size, and you can see that drops pretty significantly from about 100 neighborhoods, 100 census block groups, 100 in the beginning before the pandemic, in the beginning of the year before the pandemic, to just over 25 now, and even a little less in April when the pandemic was at its worst. Network density similarly falls, and correspondingly, we see sort of evidence for a mechanistic connection here. In April, as those measures reach their lows, dissimilarity index, as you can see over here on the left, crested. So as one goes up, the other goes down. At least that's what the evidence seems to suggest. We'll obviously use the 5 boroughs in New York City, like any good city of America, to check out further what's going on You see a similar pattern here. New York City had early cases of the coronavirus. So you see a slight drop in March before a steep drop in April, and a dense network becoming a far sparser network throughout the pandemic, and concluding at the end of the year with levels that have still not recovered since the beginning of the pandemic. So the correlation matrix, very, very different here. November also stands out as a very different month. And that's interesting because it suggests that there are different things going on in New York, but also that maybe the travel season in November and December impacted New York more. Either way, you see some much stronger shocks to correlation here. Perhaps as people decamp from the city. New York was famous for that during the pandemic, but there's more exploration to be done there. What we see here when we replicate the analysis of dissimilarity is that community size fell again, and network density fell, and dissimilarity index rose, although it's a little messier in New York, and you see some ups and downs throughout the pandemic. So with that in mind, with those two sort of exemplary case studies, let's move across the whole country. So here's a map of all the different cities that I looked at. These are the 100 largest metros in America, and you can see that the correlations here looked at just correlations from the given month to January are pretty strong in the beginning of the year, and then they really plummet in certain regions, usually in the Northeast and the West Coast in April. But that's just meant to be a little teaser. Let's move on to a sort of more fixed way to explore it. Here I have cities on the y-axis, months on the x-axis, and the fill represents the correlation with January. So only with reference to January. So how similar is our February, March, April, May, etc. to January? You can see that April is pretty much the worst month across the board, although some cities are there are these streaks here that suggest that that some cities were more stuck in a sort of pandemic mode, but other cities were not. It's ordered by latitude. So Miami's down at the bottom, and Spokane, Washington is at the top. We go from south to north. And you can see that definitely many of the cities that had the least, that experienced the least of the mobility shock are down in the south, with some exceptions like Boise City. That sort of glaring bright blue streak near the top it's north technically, but it's not really a northern city. It's more in the Mountain West country. So latitude is part of the story, but it's certainly not the whole story, I guess, is what this chart shows us. We can see it more concretely here. It's really about the Northeast and the West Coast. Miami is sort of part of a class of coastal cities, it looks like, rather than part of the South. But yeah, in general, you see that there are the most serious shocks to the network structure in April, a little bit in May, and then things start to get back to normal. They start to get back to normal quickly in the Southeast, but elsewhere as well. So those are just some stylized facts here. Now let's get into the results of the analysis. So network density, the largest cities have the lowest densities. As you can see, I selected 5 cities to look at. They're all pretty big cities, and they're all way down at the bottom. But you can see that network density declined across the board. So that could easily be something that we can use to explain our results later. When we look at degree centrality, you can also see a similar collapse, although that recovered more. Network density came down and stayed down. Degree centrality came down and came back up. You can see in the previous chart, but it's also evident here that Houston and Phoenix, which are sort of Sunbelt cities, are different than the northeastern and sort of Rust Belt cities, in that they really resisted much change to mobility during the pandemic. So there's clearly a lot of geographic heterogeneity in these results. Now, when I look at index of dissimilarity here, it looks quite messy.
5 minutes.
Pardon?
5 minutes.
Oh, perfect.
Okay.
Here it looks like there's nothing really going on. But when I chain to January, so every city is related to itself rather than all other cities, you can see that many cities in gray and also in the Bay Area in that sort of gold saw large changes to dissimilarity in April. I wanted a way to get at how this manifested quantitatively. So what I looked at, what I essentially asked was, in how many cities was the worst month of the pandemic April, when we saw the biggest drops in degree centrality and the biggest drops in network density, the biggest changes to structural correlation. And you can see that in 50 of the 100 cities, April is the worst month for segregation, for experience segregation. Now, this isn't perfect. Obviously, it's only 50 out of 100, but you can see in the chart that it's clearly different from chance. There's something going on here. And it's also a bit of a sanity check, because it says that maybe this dissimilarity index measure is capturing something. This is sort of intuitively attractive. I then did, as I said, a series of robustness checks. These are all going to be, entropy and Gini are both going to be sort of adjusted so that you want to look for the same thing. High is high in all of these. So it's a little messier for entropy, but April is still the most common month for peak experience segregation. For Gini index, again, messier. Gini index is closely specified to entropy, so that's why these charts look pretty similar. But it's still just, it's a nice robustness check to see that there's still a there. So what do we have here? I think this is compelling evidence that communities became more homogeneous during the height of the pandemic, that people were less likely to travel to more diverse places, instead opting to visit venues in those neighborhoods similar to their home neighborhood. It's a pretty narrow definition. It's not perfect, but it's still an interesting finding. InfoMap community detection is noisy, I should mention. It uses a random walker, and each time it is different. So our results are not conclusive. I have some techniques that I'm going to explore to create more robust results. And we still need to explore what predicts these changes. So there's clearly differences, there's clearly heterogeneities, as I've shown, and I need to figure out what explains them. Further, there's still work to be done by segregation, on segregation by class rather than race, and whether or not there are sort of rural, urban, suburban differences. And all of that I have preliminary results on, but not in time for this paper. So if you have any questions, I am happy to field them.
You mentioned that your results, they're not conclusive. It's more you're exploring, doing exploratory analysis as well. They're not conclusive yet. But definitely you found that April, it was the extreme month, let's say, but in your map you saw that I think south in the coast, you have some differences in there. I think you mentioned, but could you expand a little bit more, like why do you think, or what do you think about what lead these differences, and what you expect, which directions you will expect to lead your work in the future?
Yeah, I think there are a couple things going on I think a lot of states in the South, led by Republican governors, didn't really have strict coronavirus lockdowns. But
Okay.
another thing that you see is that there's just different patterns of degree centrality and network density in those cities even before the pandemic. So what I think is that a lot of these automobile centric metros they're designed differently. They have higher degree centrality. People travel to more areas in general. I think there's just a little less concentration because they're sprawling metros. So there's just a different sort of urban morphology down in the South. And yeah, I'm really interested to know how that morphology explains changes during the pandemic. I think the driving is key. I think people in the beginning of the pandemic were terrified of public transit. So I just need a good way of getting at that hypothesis. I haven't quite figured out how to test it.
And another curiosity, you mentioned that you will maybe try to expand your work, like by testing some other techniques or other methods. Do you already know what type of methods you try to apply?
Yeah, I mean, in addition to just putting some things like income and education in maybe a regression framework to explain these changes, I also want to create more definitive communities. There are certain techniques for essentially running community detection over and over again and tagging communities, so you have the modal community, the community that comes up most for each neighborhood, so that it's robust. It's something that's occurred multiple times, not just fluky in one run of the InfoMap algorithm. There are some techniques for doing that, but they're pretty involved. So I need to get into that.